I'm Anil Kumar, sharing with you some questions from previous test paper. We are working on quadratic equations. Here is a communication question for you. Lisa claims that the discriminant of a quadratic relation will never be negative if the relation can be written in the form y equals to a times x minus r times x minus s. Do you agree or disagree? Explain. You can always pause the video, answer the question, and then look into my suggestions, right? Okay. Now we are given the equation as y equals to a times x minus r times x minus s. Now we'll assume here that r and s are real numbers, right? Real numbers. This is our assumption to answer this question, right? That is very important. I should say non-zero, right? If they are zero, even then it works. R and S are real numbers, right? They could be any real number, right? Not imaginary numbers. So that is kind of important to understand before I answer this question. Okay. Now, when we have this equation, then you can see that for x equals to r and x equals to s, what is the value of y? Y is equals to 0. Perfect. If I write x equals to r, then we'll have r minus r, which is 0. 0 times anything is 0, so we get y equals to 0. If I substitute x as s, even then this s minus s will be 0, and so we get y equals 0. So that really means that we are talking about 2 points which are x value r, y value 0, and s 0. What are these? These are x-intercepts. That means that the quadratic equation has 2 solutions. The quadratic equation has 2 solutions, right? Which are at x equals to r and x equals to s. And these are real solutions. These are real, right? Now, if we have 2 real solutions, now there could be a scenario where r is equals to s, right? So if r is equals to s, then we have 1 solution. Is it okay? That is also possible. So, and r and s can also be equal to 0. We can also have r equals to s equals to 0. In that case, so these are different scenarios. Do you agree with me? We could have these scenarios also. If r equals to s, well, it could be any other number. R equals to s equals to 0. In that case, we get y equals to ax square, right? So if that is the case, that is to say, if these are the 2 cases, then we have 1 real solution. Is that okay? Now, what do you infer from here? Okay, so let's look into the question once again to answer, right? I'm taking my time so that you get your time to answer this question also, right? Okay, now here we say Lisa claims that discriminant for a quadratic relation will never be negative. The discriminant D is what? Is b square minus 4ac, right? Now b square minus 4ac, if it is, we are saying, will never be negative. Will never be negative. That means if it is negative, it means what? It means no solution. No real solution. If b square minus 4ac is equal to 0, that means 1 real solution. If it is positive, that means 2 real solution. Is it okay? Amongst the scenarios which we discussed just now, there's possibility of 2 solutions or 1 real solution, right? Since r and s are real, we'll always get a solution. So we are working in this group. Either we have a solution, 1 unique, or we have 2 real solutions. We'll never have no real solution. Is not the case. And therefore, we can say that the claim is correct. So Lisa's claim is correct. Discriminant D can never be negative. So I'm again putting this condition if R and S belongs to real numbers, right? So at this stage, let us be very clear. R and S are real numbers. If they are complex, then it's a different scenario altogether, right? In that case, Lisa could be correct. But generally, when we write this equation, we mean R and S are real, and therefore I've made it very clear. I hope that helps. I'm Anil Kumar. You can always share and subscribe to my videos. And remember, in this question, it is very, very important to specify that R and S are real numbers. If they are not, if they're complex, then Lisa could be correct, right? That means we have imaginary roots, okay? So in that case, this could be negative, right? So anyway, I hope that helps. Thank you and all the best.